Hi and welcome to my third video on the fractions component of this. So now solving equations with fractions in them. Again, we're not going too far. I just want to make sure you're ready for year 10, that's the main thing. So I've got three examples here. I've picked them all for different reasons. I want to give you some examples of really key skills, key ideas, or maybe just simplification techniques that will really help you out. So let's start with the first one. I haven't got much space because actually it's not too bad. I just want to remind you that if you have a linear equation like this with a fraction in it, the fraction is really easy to deal with. And I'm going to do this using the most common method, which would be to, and I'll try and use colours here, subtract 7 from both sides. And so that gives me x over 3 is equal to 4. And then recognise that the opposite to dividing by 3 is to multiply by 3. And that gives me that x is equal to 12. So there's my solution to that one, just following that same procedure for linear functions, even though it's got a fraction in it. Sometimes people will look at a fraction in an equation and go, it's too hard. It's actually not that bad in that type of example. This one is pretty similar actually. We can't just follow that procedure, but again, it's just a type of equation that you have where you've got x in two cases, in two situations, but it will simplify nicely. So I'm going to show you how to deal with this one, and I'm going to follow a very particular rule. This is a rule that I always follow. And that is that in almost all cases, if you have an equation with fractions in it, the first thing I want to do is get rid of those fractions because they're a real pain. And simplifying, adding, subtracting fractions is really hard, and I want to avoid that. So what I'm looking for is an opportunity to remove the 4 and the 3. You remember in the first example, to get rid of this 3 in the bottom, we just multiply by 3. I'm going to do the same thing here. I'm going to do it all in one go, and I'm going to show you how you can do it. So I'm going to multiply by 3 to get rid of this 3 here. But I also want to get rid of that 4. So this 4 over here. So to get rid of that 4, I'm going to also multiply by 4. And hopefully you can see that in total, that's going to mean I'm multiplying by 12. Because times 3 times 4 is times 12. So what I actually want to do is multiply by the lowest common multiple of 4 and 3. Which in this case is 12. It might be something a little bit simpler in other cases, but it's 12 in this case. So I'm going to multiply everything through by 12. And to keep this simple, I might show an extra line of working that you don't necessarily need to show. So 12 times 3x over 4 minus 12 times 2x plus 1 over 3 equals negative 12, because negative 1 times 12 is negative 12. I've done that deliberately because I'm going to do some simplification now. The 4 and the 12 simplifying, that leaves me a 3. The 3 and the 12 simplifying, that leaves me a 4. So however you deal with that, that's fine. You don't necessarily have to show this full line of working, but that really makes, it's about setting up procedures that work every time, and that's one procedure that works every time. So I'm left with, the 4's gone, the 12 simplified to a 3, I've got 3 times 3x, which of course is not that, 9x. And here I've got 4 times 2x plus 1. The 3 and the 12 are gone, so it's minus 8x plus 1 equals negative 12. Now I'm going to expand the brackets and then I'm going to solve. So 9x minus 8x minus 8. So it's negative 8 times positive 1 gives me a negative 8. Don't ever forget that. Negative 12. Now 9x minus 8x, this leaves me with x. I'm going to add 8 to both sides to fix that problem, and I'm left with 9x minus 8x is x, and negative 12 plus 8 is negative 4. And there's my solution. X equals negative 4. Fine. This is complex, but it's also doable, and it's also very procedural. So don't forget that. Now my third example here is probably mathematically the most complex. It's not just a simple function, but actually mathematically it works out a lot easier than this one. So what you have to recall here is exactly what we did there. Get rid of the fraction as early as you can. What's causing the problem here? Divide by x. How do I deal with that? Multiply by x. So I'm multiplying by x, and I get, I'll do this thing here again. So I get x times 3x minus 1 over x equals 2x. And of course, we don't really have to do this because we know that leads to that. That's why we multiply by x to get that cancelling. So I'm left with 3x minus 1 equals 2x. And when I expand the brackets out, I get 3x minus 3 is equal to 2x, and then I can, well, let's just do this, probably the shortest way. I'm going to subtract 3x from both sides. I forgot to do this in yellow. That leaves me negative 3 is equal to 2x minus 3x, which means that negative 3 is equal to negative x, and then all I need to do is multiply by negative 1, and it makes it 3 equals x. Or I could write that now as x equals 3. And there's my answers. So let's look at the procedure. I mean, this looks really cool. I'm looking at this going, oh, that's cool. I like that. Nice maths. But it is really procedural, and anybody can do it if they understand the procedures. They're willing to apply them, and with an ounce of practice, that really helps. So all the best.